If a penny is thrown off the CN Tower, can it actually kill someone? By Tyrus Gibson and Zach Graves. So our key component is the final velocity, and to find the final velocity, we have to label all our variables, like how tall is the CN Tower? We know the Skypod, the tourist attraction, is 447 meters tall, and we know that the penny is thrown with no initial y velocity, or perfectly horizontal, and we know the acceleration of gravity on Earth is negative 9.1 meters per second squared. Since the CN Tower is so tall, we need to figure out if the penny reaches something called terminal velocity. Terminal velocity is the constant speed that a freely falling object eventually reaches when the resistance of the medium through which it is falling prevents further acceleration. The equation for this is the square root of 2 times mass multiplied by gravity over density times projected area, that should be a big A, multiplied by the coefficient of drag. And when we plugged all these numbers in, we found that the terminal velocity is 28.8 meters a second. Interestingly enough, this number is almost identical to what the Mythbusters discovered in one of their episodes. So, now we need to figure out if the penny reaches terminal velocity. To do this, we're using a Big 5 equation and plugging in the terminal velocity, 28.8 meters a second, into V2, and then solving for displacement. This will give us when the penny hits the start of terminal velocity. So now that we've figured out the penny is increasing speed for 42.28 meters, and then after that holds a constant speed for 404.72 meters. Because the terminal velocity makes the velocity constant, somebody could be standing at 42.28 meters, and the penny would hit them just as hard as if they were standing at the bottom of the CN Tower. For comparison, the Statue of Liberty to the top of the podium is 46 meters. Therefore, this means the final velocity of throwing it off the Statue of Liberty versus the CN Tower would be the exact same. We've discovered through our research that somebody with a good arm can actually throw a penny faster than the terminal velocity of the penny. So, that means if you were to throw a penny as hard as you could off of the CN Tower, it would actually be slowing down until it hit terminal velocity, meaning that its initial velocity would be faster than the final velocity. So now we know that the final velocity of the penny is 28.8 meters a second, and we discovered through our research that the mass of a penny is 0.00235 kilograms, and the force required to fracture someone's skull is 4,900 newtons. So now we're working backwards from the numbers that we found F net, which is 4,900 newtons, the force needed to break someone's skull, and the mass of the penny to find the acceleration, which is 2.085 times 10 to the power 6. Then we're going to plug this into the Big 5 equation, and we're going to use that to solve the minimum velocity needed to fracture someone's skull. Assuming a point-blank range, the penny would need a velocity of 2,042 meters a second to enter the skull, which is much higher than the terminal velocity of 28.8 meters a second. So Miss Jones always insists on a pictorial representation, so we've devised an experiment to prove once and for all that a penny off the CN Tower cannot kill you. As previously discussed, I can throw a penny faster than its terminal velocity, so any damage that I do would be greater than what the penny would do falling from the CN Tower.
Okay, let's take it back. It didn't enter! It didn't enter! That means since the terminal velocity is less than what I can throw, it can't actually penetrate the skull if it were to hit him. So that means Zach's alive! Zach! Yeah!
For safety reasons, we threw it at his back, but if it can't enter his back, there's no possible way that it could enter his skull. Through the fact that both Zach is alive and through our math, there is no possible way that a penny thrown off a CN Tower can kill someone.